Network Dojo.
All right. Sometimes other things that we can, maybe run into, and we might not hit rules that we want. So being able to do things like validate group memberships, validate endpoint profiles can be helpful in case maybe we're not hitting the rules that we anticipated hitting. The identity store, the main use case for knowing what identity store the user was in is kind of this last one that we talked about. Know so that you can go to that identity store and make sure things are accurate when things aren't going quite right. We looked at that information in the last video, so I won't rehash how to look up the group memberships. The last video talking about the auth logs I did, we looked at that, so let's not repeat ourselves. Okay, getting into the EAP and the different authentication protocols and a few things to look at specifically with those. So if we're trying to do an EAP-fast authentication and we're running into problems, just some tips about this. Every EAP-fast auth that we do in the lab will use PACs, and they will use username and password. So technically EAP-fast supports other methodologies, certificates, EAP-TLS, and some other stuff. But what we do, PACs, username, password, so you can keep it with that context. Ensure that EAP-fast with MS-Chat v2 is enabled because the inner method of every client that uses EAP-fast will be MS-Chat v2, whether it's the AnyConnect client or whether it's one of our lightweight APs doing wired.1x with EAP-fast MS-Chat v2. It's always MS-Chat v2 as our inner method, so we don't have to worry about the other ones. Underneath the allowed protocols configuration with EAP-fast, make sure that both authenticated and anonymous PAC provisioning is enabled, which it is by default. This will ensure that there's no problems at all with anything PAC related, or it shouldn't be. And you might see that things just take a couple of attempts right off the bat, because the first part of EAP-fast is, the client checks, do I have a PAC provisioned from this Radius server? If the answer is no, we do PAC provisioning, and at the end of a PAC provisioning process, it's an access reject, so it kicks us off the network. Then we re-auth, this time with the PAC, we complete the authentication, and we're up. So we saw this when we talked about troubleshooting, I believe, the wired.1x type stuff, and in my videos talking about wired.1x, where, you know what, the APs, when they do their EAP-fast authentications, you see the auth fail, but that was just because of the PAC provision, and then the next time that it succeeds. So if you see one failure, no biggie. If you start seeing multiple failures, okay, it's time to look at troubleshooting this. When we use PEEP, ensure that PEEP with MS-Chat v2 is enabled. Again, MS-Chat v2 is always the inner method that we use for everything. Make sure that we know how to verify which server cert is in use, because the client might be configured to look for a particular server certificate or that it's signed by a particular CA that it trusts. And so let's take a peek at a few of these things. In the allowed protocols list, I didn't show you the EAP-fast stuff, so I'll do the PEEP and the EAP-fast stuff here. Again, PEEP with MS-Chat v2. We don't really care about the allow password change. I mean, it's checked by default, and that's fine. If they unchecked this part, I don't think it's going to cause a problem. EAP-fast, again, we use MS-Chat v2 is the important part. We always use PACs and allow anonymous and authenticated in-band PAC provisioning. If we have all of these selected, we should be good here. Now on the PEEP, how to validate which certificate it's using for the server certificate. When we look at these system certificates within our server, we want to look for the one that has EAP authentication associated with it. This is the one that we're sending down to the clients, and the clients could optionally validate this certificate. And from here, we can see on the right-hand side who issued it. So I know that this certificate was issued by a CA named Network Dojo-Win12-CA. This is different than my self-signed cert, which was issued by ISE.NetworkDojo.local. So the cert that has issued to and issued by as identical, that's a self-signed cert. Clients might not trust that. Oftentimes they don't trust that. Whereas certificate signed by a, your organizational CA cert, a public CA, those are generally more likely to be trusted by the clients. And so I would assume in the lab there will be a CA signed cert that either is pre-installed or that they ask you to install. And again, that might be important during any PEEP authentication. So EAP authentication, if it's not on the right certificate, you would just go into the cert that you want to have EAP authentication turned on, edit it, come down, say EAP authentication. That will take it away from the other cert and apply it to this cert. And then from there on, it uses this cert during EAP authentications. So what if the client actually did reject the server cert? So we're using the wrong server cert. The client doesn't like it. The client rejects it. This is the type of error you would see. PEEP failed. In this case, it was a PEEP auth. Failed the SSL TLS handshake because the client rejected the ISE local certificate. So that's the error you would see if that's the case. Either you haven't installed the appropriate cert yet, or the cert's installed, but it's not configured for the EAP authentication part. Oh, I didn't mean to go out of that. Back in. Okay, ETLS. So ETLS is one of the most common protocols in the lab. Usually something will go wrong with it, so let's make sure that we understand all the different parts that can cause things to go wrong with ETLS authentications. Again, this is another auth that has a server cert, so make sure that you know how to check which server cert is in use so that the client can validate it if it's configured to validate it. Make sure that the CA cert that signed the client certificate is installed and set to be used for client validations. This is actually a really common place where troubleshooting is caused in the lab for ETLS authentications. What we're looking at here is the list of trusted certificates. These are the certs that could be used to validate client certificates during an ETLS auth, but they only will be used if they have the endpoints option enabled on top of it. So for instance, here is my Network Dojo CA cert. Now a classic problem that we'd run into is they pre-installed the CA cert for you. They did you such a nice favor, but of course they didn't actually check the box to trust for client authentication in syslog, and so it would look like this. If it looks like this, yes, it's a trusted cert, but we do not use this cert for ETLS authentication verifications. We got to check this box, make sure that we're okay. Now, really tiny potential sort of a thing, but thing that can cause problems. There is a process called a certificate revocation check. And the idea there is when we're verifying a certificate, you know, the cert might have been legitimately created by a CA that we trust, but maybe that cert somewhere along the line had been compromised. And so they reported this to their CA provider and said, hey, this is compromised. This should not be used anymore. And so the CA provider adds it to something called a revocation list. And it's basically a list of all the certs that it has created that should no longer be trusted. And so I doubt that they would ever do this, but they could potentially configure this to say, you know what, let's go ahead and double check the revocation list, download the revocation list, and maybe some misconfigurations in here could potentially cause a problem. I don't know. I haven't really played around with it, but I just wanted to let you be aware of it. This should just normally be all turned off. And again, this is a pretty advanced thing. I doubt that they would get into this, but just for your awareness. Normally it's just this box right here didn't get checked. All right. And if the CA cert needs to be installed, they'll tell you where it is. You install it, make sure you check that box, and then you're going to get around that error. Next up, verify the CA profile settings. So the CA profile says a few things. Number one, what attribute in the certificate do we use for the username? And it's also going to tell you if you are integrating with Active Directory. So it just needs to be configured to look in a place that has information. And if it is integrating with AD, we just have to know that so that AD integrations are correct and that we have the appropriate user accounts in there, which should all be kind of an automated thing. And then make sure that we have proper data on the ISE server, because if the ISE server thinks that the client cert is not yet valid or expired, it will also reject that by default at least, although we can turn on a feature to ignore that part of it. All right, so let's look at some of the errors and then we'll dig into that. So here's ETLS failed TLS handshake because of an unknown CA in the client certificate chain. This is where the client certificate was sent to ISE. but it was signed by a CA that we don't trust. So that was kind of what I just looked into. That CA list, we need the CA cert installed and with that endpoints feature enabled on top of it. Okay, so some errors related to the CA profile. One is that the username attribute is missing in client certificate. And it even has a nice resolution here. Not a whole lot of us are really well versed in that CA profile. So this resolution, check right certificate attribute is selected in the CA profile as username. Ensure the user certificate contains this attribute. I mean, that's like, yes, exactly that. Do what they said. So you go into the CA profile, which is in the external identity sources. Now we should only have one. If we have multiple, you would want to look in the auth log or in the auth rules to see, okay, which CA profile is it actually using. But once you know which CA profile it's using, here is where we determine which field is used for the username. Now, every cert has a common name. It's a required field. But not every last one of these other ones is necessarily required. So, for instance, this is one that I typically use when I want to cause this error. If I say DNS and there's no subject alternative name DNS entry in the cert, that's where we get the no username error from. So you would come in here, and unless they tell you to use some other field, just go right back to common name. You'll always be good with that. And then if we are engaging Active Directory, but Active Directory cannot find a matching user, we actually get this error, identity resolution by certificate failed. So when we do want to integrate Active Directory, that kind of forces us into only accepting certificates that are matching to an AD user. So if I have a certificate that is not related to any sort of an Active Directory entity, like in my racks, my autonomous AP certificates, if I have a workgroup bridge to an ETLS, that cert is not referencing any Active Directory user. It's just a standalone cert that was created without any Active Directory integrations with it. And so in that case, and if I did turn AD integration on, this is the error that I see. Unfortunately, the resolution here doesn't really help us too much, but we need to go to the CA profile, and if it has either your specific Active Directory entry in here or just AD in general, there's really only two ways to get around this. Either we just turn this part off, go back to not applicable, and that way we don't integrate with Active Directory, or we're going to have to configure an authentication policy such that when authentications for the subset of devices that aren't AD integrated come in, they hit one either overall rule or an identity store rule that points them to a CA profile that doesn't integrate with AD, and then another rule that when we match this, these would be the AD user-based identity store rules that we would reference a CA profile that does integrate with Active Directory. Now the trick here is we can't just write a rule that says, oh, well, if it's an AD user, use this. If it's not an AD user, use that, because we don't know that at the time of processing these rules. We only know basic information at the time that we process these rules, such like we would know the network device it's coming from. We would know that the basic type of auth, like 802.1x or MAB. I think once we hit the identity store rule, maybe we know the protocol, like PEEP or EFAST, but maybe not. That one I'm not 100% sure on. And so it might be more broad, like, okay, auths coming from autonomous APs, use this non-AD CA profile. Auths coming from anything else, use the AD integrated CA profile. But, I mean, I feel like we're starting to get into the weeds a little bit here. I mean, the odds that we get a certificate, multiple certificates, one of them integrated with AD, one of them not integrated with AD, at the same time are low inside there. But if we do have that scenario, these are the two ways to get around it. We either have to separate out the authentications, and they each have their own CA profiles that they use, or we just turn off AD integration altogether at the CA profile level. You can still be AD integrated for username password authentications, but we just can't leverage it for certificate authentications. All right, host lookup. So just a couple things left here. So if we're doing a host lookup, that would be a MAC address-based lookup, and we're trying to troubleshoot that. So one of the things you have to ask yourself, okay, do I want to treat this host lookup as an endpoint lookup or as a username password lookup? Because we can really do both if we want to. So we have some flexibility there. Oftentimes I prefer endpoint lookups just because it's a little bit simpler and that's more in the spirit with what a host lookup is. But there are times when I do use a username password lookup to avoid a lot of work for one specific use case. So if you want to treat it as an endpoint-based authentication, pay attention to things like the password and the calling station ID settings of the associated network device profile. What am I talking about here? So different types of devices or different types of authentications on the same type of device, even though that they're MAC-based lookups, can sometimes be formatted a little bit differently in the radius request. And the network device profile is what specifies, okay, when a MAC auth happens and I want to treat it as an endpoint lookup, are there any security enforcements I want to enact? And if I do, if the auth doesn't match that, I will actually fail out the auth. So let's take a look at that. As I mentioned before, all devices should be in a network device profile called Cisco. And I would do everything in my power not to create another network device profile and leverage that in addition to the Cisco, because that opens up a can of worms. So what does the Cisco network device profile say how it wants to treat host lookups? This used to be in the allowed protocols list back in earlier versions of ISE, but now it's moved underneath here. So when we process host lookups, they should come in via Passkey, and that's really always the case. But we have one enforcement check, that the calling station ID, which is normally the MAC address of the client, equals the MAC address, which is the username field of the host lookup. This is almost always true. The one time I know it is not true is specifically for mesh APs doing external MAC lookups, and only when a map is wirelessly joined to a wrap and then trying to join up to the controller. That is the one use case where I know that this is not true, and I believe what happens is the calling station ID field is just blank in that case. But unfortunately, if we try to treat it as an endpoint lookup, it fails out because of this. So we can alternately treat those types of authentications as a username password lookup, kick it out to our internal users repository, and create an account for the MAC address and the password that matches the MAC address. So this is how the mechanism works in terms of how do we treat a host lookup, and this is the security enforcement in play for the Cisco network device profile, which everything uses by default, unless you do something special. So just have that in your awareness. Know that you usually don't have to worry about it at all, except for that one mesh scenario, which mesh is the less popular special AP mode anyways, and so it's probably not super likely to happen in the lab. So of all the MAC filtering in the lab, generally there's no problem treating it as an endpoint lookup. Now, if you do decide that you want to treat it as a username password authentication, that's fine as well. Really all you need to do is whatever rule this authentication is hitting, the identity store list should include the endpoints list if you want to treat it as an endpoint, or a username password repository if you want to treat it as a username password, and the one that we would configure things in would be internal users. So for instance, if auths hit the default rule, which things like AP authorizations do, those mesh authorizations hit those as well. By default, that uses the all users identity store sequence. So if you want to treat it as an endpoint lookup, make sure you add internal endpoints to the all user ID stores identity source sequence. That way it'll look for it there, and if it finds it there, success. Now, if you want to treat it as username password, you just also have to parse username password based identity stores as well. And so again, that all user identity store, it's already going to look, I think first up is the internal users repository. And so it will look in the internal users repository, and then you just need to create an internal user. So I would head into identities, user, and create a new one. Now the only catch is that if I want to create this user, the password is going to equal the username. And by default, that is not allowed, so I have to go to settings, user authentication settings, and I've already done it on this, but you need to lessen the restrictions here. So in other words, the username, the password must not contain the username. This is checked by default. You got to uncheck this. You also probably have to uncheck the fact that you're using uppercase alphabetic characters. So just make it very permissive from a password policy, and then you should be able to create the username, and then the password is just a carbon copy of the username, all lowercase, no delineators, so just 12 hexadecimal characters at that point. So with host lookup, usually the only error that we hit is couldn't find the endpoint. So know how to just handle either scenario, endpoint, or user lookup. You should be okay there. Last up, Passkey troubleshooting. So this is what we're going to troubleshoot. Anything that's not an EAP authentication and anything that's not an endpoint lookup. So these would be management authentications. This would be putting in a username password into a local WebAuth guest portal. Those come in with Passkey, and they are username password based authentications. And in this case, you just need to know how to, well, all the troubleshooting we've talked about this point really applies to this, but usually the tougher thing is potentially, differentiating between different types of these authentications coming from the same device, because they can look very similar to each other. So for instance, a management-based authentication versus a web-based authentication coming from the same device, there's only a couple little differences between them. And so we kind of talked about this when we talked about the auth logs in the previous video, and I tried to point out some of the differences between them. So just know how to differentiate in your rules between it, and at that point, you should be okay. But things like couldn't find the username, bad passwords, the troubleshooting for that, really, we've already talked about those things. So that is the end of this video. A lot of things that can go wrong with authentications. We have a number of different protocols that we interact with, each with different things to remember about them. So experience is going to be the best teacher here. Practice breaking things. See how many ways you can break things, and what does it look like when you break it. So start with a working scenario, and then break it one way, break it another way, break it a third way. And you'll start to see, okay, yep, these are the errors I'm used to seeing. These errors come up when I do these different things. And I think that's one of the best ways to really just lock a lot of this stuff in.